Hey, what's up guys? This video is for section 2.6, ratios and proportions. So first of all, let's talk about what is a ratio. So I had the definition here on the screen. And a ratio is a fraction that compares two numbers. So it's just a regular fraction, but you guys have some units and you want to compare two different units or two different numbers. So here's an example. Yesterday in the gym, I ran 4 miles in 30 minutes. Now you guys understand what that means in 4 miles. That's the distance that I ran, and it took me 30 minutes to do that. Now the ratio that actually explains what happened is a fraction. So here's the ratio, 4 miles over 30 minutes. So what I'm trying to say here is that I can run 4 miles in 30 minutes. So that's a ratio. Ratio is just a fraction that tells you what to compare from the numerator and the denominator. Now, if you guys take two ratios, so two different fractions, you can make a proportion. So this is a definition for a proportion. A proportion is an equation that states that two ratios are equal. So you have two different fractions or ratios in this case, and we're saying that they are equal. So that's what's called a proportion. And here's an example. 8 over 16 is the same as 1/2. So we have a ratio, a fraction, 8 over 16, and we're saying that it equals 1/2. And that's because you can reduce the fraction. You can divide this by 8, this one by 8, and 8 divided by 8 is 1, 16 divided by 8 is 2. So 8 over 16 is the same thing as 1/2. So this is called a proportion. When you guys have two ratios and we're saying the two ratios equal to each other. Now the fractions, the ratios don't have to look the same, but they will be equal. Now today we are going to solve proportions. So to solve proportions, we need to use one property called the cross product property. So I'm going to explain what that is, and then I'm going to show you guys how to use it when you solve proportions. So if you guys have a proportion, A over B, so let's say those can be numbers, they can be variables, and we know that it equals C and D, well, we can say that A times D equals B times C. Now let me zoom in on this one so I can explain a little bit more. So what I'm saying here is that if I take the numerator of the first fraction and I cross multiply, that's where the cross product name comes in, by D, so A times D, that's going to be the same if I take the denominator of the first fraction and I cross multiply by the numerator of the second fraction, B times C. So those products, those multiplication will be equal. Now notice what happens when I cross multiply. We had a proportion, we had two fractions equal to each other, and when I cross multiply, I have an equation, but we don't have fractions anymore. So that's what we can do when we have proportions and we want to solve the proportion. Now before we actually solve, let's go ahead and compare how to know if ratios are equivalent or not equivalent. So I have two examples here, 3 over 7 and 9 over 14. I want to know if those two ratios are equivalent. If they're equivalent, that means that we can make a proportion. So this is the way you guys check. You will take the numerator of the first fraction and you are going to cross multiply by the denominator of the second fraction. So I'm going to multiply 3 times 14. And then you guys are going to take the denominator and you're going to multiply by the number across from it, the numerator, 7 times 9. So I want to know if these two products are equal to each other. So let's go ahead and multiply. So I multiply those numbers and I got 42 on the left side equals 63 on the right side. Well, guess what? That is not true. So I'm just going to put a not equal in the middle of the two numbers. So the question is determine if they're equivalent ratios. So the answer is no, they are not equivalent. Let's try the next example here. I'm going to do the same thing. I want to check if 7 over 8 is equivalent to 42 over 48. So I'm going to cross multiply. So I'm going to take the numerator of the first fraction, multiply by the denominator. So 7 times 48. And I'm going to take the denominator of the first fraction and multiply by the numerator, 8 times 42. And I want to know if they're equivalent. And I multiplied, I got 336 on one side, and the other product, I got also 336. So I can say these two are equal. 336 equals to 336. So what that means, guys, is the two ratios are equivalent. So they're the same type of ratio. So we can make a proportion out of those two ratios. But we're just going to put here, yes, they are equivalent, because when you cross multiply, we get the same product. So now let's actually solve the two ratios, the proportion for the variable that is given to us. So I have three examples here. Notice that the variable can be either side of the proportion, on the left side of the equal sign, on the right side. So this one is on the top right. This one is on the top left. We have a negative variable. This one's on the bottom right. You can also have on the bottom left. So the variable can be anywhere in that proportion. But the idea to solve a proportion, you're just going to use the cross product property. So we want to solve for x. So I'm going to multiply the numerator here times the number across, and I can do that because this is a proportion. Notice we have a fraction, 4 over 6 equals x over 9. So we have one fraction equals another fraction. There's no plus another fraction. Let me give you guys just a quick example of what is not a proportion. Let's say that you guys have 4 over 6 plus 1 over 3 equals x over 9. So this is not a proportion here because this fraction is adding to this fraction, and we don't have just two fractions. We actually have three. One fraction, two, and three fractions. So this is not a proportion. This is going back where you have to multiply the lowest common denominator if you want to get rid of the fractions, and then you guys solve for x. So let me just erase that. And this is just to give you guys an idea what is not a proportion. So going back to here, I am going to multiply 4 times 9. So I'm going to set up that here, 4 times 9. I'm going to bring down the equal sign, and I'm going to multiply the denominator times across, 6 times x. So 4 times 9 is 36. You guys are going to equal that to 6x. And you guys solve. You want to get the x by itself. So I'm going to divide by 6 here. And we get 6 on one side. So 36 divided by 6. On the other side, this turns into 1. And there's the x. So my answer is 6 equals x. Or you can say x equals 6. Now, if the variable has a negative, like this proportion here, we have a negative b. You also have to be careful with the negatives, and always double check your signs, negatives and positives. So I will cross multiply to solve. So I'm going to multiply this negative b, it is a negative, times the number across, which is the bottom, the denominator of the second fraction. So I'm going to have negative b times 5. I'm going to bring down the equals. And I will multiply 10 times the number across from it, the top number, 4, 10 times 4. So we get negative 5b on this side, negative b times 5. You always put the number in front of the variable, and it's a negative 5b equals, and we get a positive 40 on this side. You want to get the variable by itself. So I'm going to divide by negative 5 here, and this turns into positive 1, negative 5 divided by negative 5. So we get b equals negative 8. Now, if you guys have a fraction, 4 over 5 equals a negative 12 over x. Now, this negative is in the middle of the fraction. If you guys have that negative in the middle of the fraction, I want you guys to take this negative to the top number. Now, mathematically, you can take it to the bottom, but only one of those terms will have a negative, not both of them, only one. But it's very common to take the negative to the top number. So this 12 is going to be negative, and this x is going to be positive because you took the negative to the top. So to cross multiply, you will take the 4 times across from it. So 4 times x, and you're going to bring down the equals, and you're going to multiply the 5 times the negative 12 right here. Remember that you guys have a negative 12 there. So we have 4x on this side equals, and 5 times negative 12, that'll be negative 60. Now you guys are going to get the variable by itself, so I'm going to divide by 4 right here. This turns into 1. So we have x, you bring down the equals, and negative 60 divided by 4, negative 15. Now this one here is involving a little bit more on the fraction. You notice that it's a little bit different than the previous examples here. So let me go right here. You guys have 7 over a minus 4 equals 4 over 6. So on this denominator, we actually have what is called a binomial. You guys have two terms, a minus a 4. One term, two terms. So bi means 2. So that's why it's called a binomial. So the idea is the same. You guys are going to cross multiply and then you solve for the variable. It is a proportion because this one here is just one fraction. Even though you have a minus 4 on the bottom, this is on the bottom of the fraction. So this is one fraction equals another fraction. So you guys are going to cross multiply the numerator on the first fraction. So we take the 7 here and you multiply across right here times the denominator of the second fraction. So 7 times 6, you're going to bring down the equal sign, and you will take this binomial a minus 4 and you're going to multiply times the one up here. Now this is how you set up when you guys have two terms or a binomial. You're going to take the number that it's by itself first. So we had the 14, and we're going to use parentheses saying that we are going to multiply by the binomial a minus 4. Now notice that we have two things happening in this equation. We are going to multiply 7 times 6. Over here, we do have the 14 outside of the parentheses. So that means that we have to distribute, and we're going to have to multiply. So let's do that on the left side first. 7 times 6, that's 42. On the right side, we have 14 times a, that's going to be 14a, and you're going to take 14 times minus 4, that's going to be negative 56. So you're ready to solve the equation. You guys can put the line on the bottom of the equal sign if you want. You don't really have to, but I'm going to do that to show you guys my steps. So I'm going to add 56 to both sides here, which is the constant on the same side of the variable. So we know this cancels. 42 plus 56 is going to be 98. And on the other side, we get 14a. We are going to divide by 14 here. So you're going to divide 98 by 14, and the answer is 7. So 7, let me write it down, 7 equals, this turns into 1, we don't need it, a. Or we can say a equals 7. So it doesn't matter where the variable is at in the proportion. Like notice this one, the x plus 6, the binomial is on the top of the second fraction. Doesn't matter, it can be anywhere. It can be here on this side, here on this side, on the bottom, or on the top. But the idea is just to cross multiply, and you guys will solve for the variable. So I am going to multiply the numerator right here, times the denominator, so the number across. That's because it is a proportion. So I'm going to have 2 times 12, and then I'm going to bring down the equal sign, and now I'm going to multiply the 3 times the binomial up here, the x plus 6. So you cross multiply. So you have the 3 parentheses, and you put x plus 6 inside of the parentheses. On the left side, let me just bring down the equal sign here. We get 24, 2 times 12, and then I'm going to distribute the 3. 3 times x is 3x. 3 times 6, that's going to be 18, and you solve. So let me bring down the line right here. Subtract 18 from both sides. So this cancels right here. 24 minus 18, that's going to be 6. You bring down the 3x over here, and you divide by 3. So we get 2 on one side. 6 divided by 3 is 2. Over here, this turns into 1, and we just have the x. So my answer is 2 equals x, or you can say x equals 2. Alright guys, so that's it for the video. If you guys like my videos, you can hit that like button, and you can also subscribe to my channel. Make sure you guys practice, and I'll see you guys later.